So in the last session we discussed until queue interface. So we're gonna continue and complete this topic. So next topic is let's talk about Deque interface in Java. That stands for double-ended queue. The key idea is right in the name. You can add and remove elements from both ends. Think of it a line of people where you let someone in at the front or the back, and you serve from the front or the back. That makes it flexible enough to work as both a queue and a stack. So queue is basically first in first out, stack is last in first out. The two implementations you'll use are ArrayDeque and LinkedList. So ArrayDeque is which is usually the best choice because it's fast and efficient. LinkedList which also works, but ArrayDeque is the go-to for most situations. So the key methods here is we have add first, add last, which is basically put an element at the front or the back. Remove first, remove last, take an element from the front or the back. We have peek first, peek last, look at the element at either end without removing it. And if you want the stack like behavior, you can push pop, which is basically the same as add first, remove first, so let's look into a classic example, which is checking if a word is a palindrome. So a palindrome is something that reads the same forward and backward like a race car or a level. So here's how a Deque helps. Put each character into the Deque, and while the Deque has more than one character, take one from the front and one from the last, from the back. If they ever don't match, it's not palindrome. If you make it all the way through, it is. That's simple but powerful way to use both ends of the structure. So a couple of things to avoid: don't use the old stack class for last in first out anymore. It's legacy and slower. If you need stack behavior, just use a ArrayDeque with push and pop, and be clear whether you're using it as a queue or a stack. The methods overlap, and it's easy to confuse yourself if you're mixing them without a clear plan. In your lab you'll be able to use the Deque to maybe test a few things by comparing front and back, and use the same structure for both first in first out and last in first out operations, and stick with ArrayDeque as your default choice. A Deque is just a flexible queue that gives you control over both ends, so you can solve problems that need either stack or queue behavior with one structure. So that's about Deque interface. Next is SortedSet, which is a TreeSet. So let's talk about the TreeSet, which is a special kind of set in Java. So remember, a hash set gives you uniqueness but no order at all. So if you want both uniqueness and a sorted order, that's when you reach for TreeSet. So a TreeSet automatically keeps everything in sorted order. By default, it uses elements natural order. For numbers, that means ascending. For strings, it's alphabetical, but if you want a different order, you can give it a comparator when you create it. So what can you do with TreeSet? We have a few operations. We have add, let's say x, add x, and basically inserts an element but ignores it if it's already there. We have first and last. You get the smallest and the largest elements. We have ceiling. Ceiling x is basically the smallest element that's greater than or equal to x. Floor x, the largest element less than or equal to x. Subset, from to, basically gets a slice of set between two values, which is from and to. Let's see a demo. Like imagine usernames in an app. If you store them in a let me open this one. So if you store them in a TreeSet string, you store them in this one and you get a list that is both unique and automatically sorted alphabetically. That makes it easy to display leaderboards or to do lookups like give me a first username starting at m. That's where methods like ceiling, like let's say ceiling ceiling m, this basically gives the first username starting at m, so it comes in handy. Couple of things to remember, to avoid is watch out for if all elements must be mutually comparable. You can't mix types that don't know how to compare themselves, like integers and strings in the same set. And if you use your custom objects, you either need to make them implement comparable or supply a comparator. Forgetting that will lead to runtime errors. So use TreeSet when you need both uniqueness and sorted order. And remember no duplicates, no nulls, and everything has to be comparable. In labs you'll be practicing building TreeSet, checking order with first, last, and ceiling, and using it in situations like keeping sorted usernames. That's it. HashSet is for uniqueness alone. TreeSet is for uniqueness plus sorting. That's about TreeSet. Next we have PriorityQueue. So let's move to another kind of queue, which is the PriorityQueue. Up until now we talked about normal queues, which work like a line at the store, like first in first out, but PriorityQueue is different. It doesn't care about who showed up first. It always serves the element with highest priority first. So by default, Java's PriorityQueue is Min-heap, which means smallest element according to its natural order, which comes out first. Numbers comes out lowest to highest. Strings comes out alphabetically. So, but what if you want the opposite order, like max-heap, where the largest number comes out first? That's easy. When you create a PriorityQueue, pass in a comparator. For example, comparator, let's say reverse order. So which flips the natural order. So here is something really important. A priority queue is not for full sorting display. If you iterate over it with for each loop, you'll see elements in a kind of scrambled order. The only way to see items in a true priority order is to repeat call poll, which always removes and returns the highest, returns the current highest priority element. Imagine we are building a simple task scheduler. Each task has a priority number, like lower numbers mean more urgent. If we put tasks into priority queue, then each call to poll will give us the next most urgent task. That way we don't have to sort the whole list every time. We just add tasks as they come, and the queue handles the ordering for us. So a couple of things to remember is, don't expect for each loop to give you tasks in order. If you want them in priority order, you must poll until the queue is empty. So be careful with comparator. If it's inconsistent with equals, say it treats two objects as equal priority, but equals say they're different, you can get surprising behavior when using sets or maps alongside. So yeah, but priority queue always gives you the element with highest priority list, priority first. It's a min heap by default, but you can flip the order with a comparator. It's great for things like schedulers, simulations, or anything you need to process items in a priority order. Just remember, for actual sorted list, use a different collection. For processing by priority, use priority queue and poll to get items out in order. That's about priority queue. The last topic for today is stack. So a stack is the opposite of queue. So instead of first in first out, it's last in first out. Imagine a stack of excuse me. Imagine a stack of plates. The last plate you put on a pile is the first one you take off. In Java, the modern way to do a stack is ArrayDeque this. You'll see there's also java.util.stack class, but that one is considered legacy. It's synchronized, slower, and generally not recommended anymore. But so whenever you hear stack, think ArrayDeque with methods push, pop, and peek. So operations, we have push, pop, peek. So push X basically puts an item on the top of the stack. Pop removes and returns the top item. Peek looks at the top item without removing it. So when do we use stacks? They're really common in programming. For undo history, every time you make a change, push it, undo by popping. Parenthesis and brace matching, which you push when you see opening brace, pop when you see a closing one. Depth first search, DFS, which basically keeps track of nodes to visit in a stack. Let's see a scenario like a simple brace balancer. suppose we scan through a string of code. Every time we see an opening parenthesis, we push it onto the stack, and every time you see a closing parenthesis, you pop from the stack. And at the end, if the stack is empty, all braces matched. If not, something is missing. That's the kind of logic stacks make really easy. Yeah, don't use the old java.util.stack class unless you're forced to. Use ArrayDeque instead, and always check for underflow. If you call pop on an empty stack, you'll get an exception. Make sure the stack isn't empty before popping. Yeah, that's it. Stacks are simple but powerful. Just remember last in first out and use ArrayDeque for modern Java. That's it for this topic.